I'm Susan Switzer, along with Dr. Heather MacGillivary. We work for Colorado's second largest school district, Jeffco Public Schools, in the United States. Heather is the director of the Research and Assessment Design team. I work under her direction as an analyst. Our district serves 77,000 students in urban, suburban, and mountain rural settings. We will share a bit of our journey with Shiny and some details about how we leverage Shiny to meet our system's unique needs. We are not computer programmers by our training. We learned R and Shiny through the support of a consultant, our use of Data Camp, and through the community of users online. I went from being a teacher and school administrator to building and maintaining the Shiny app that we will showcase today, called Jeffco School Insights. Our professional backgrounds are important to the conversation because it was our vision for using Shiny in local government that led to our skill development in R. We hope our pathway leads others to vision-driven work in their communities. Since our school district has a wide variety of school configurations and our student population has a range of needs and backgrounds, we needed the flexibility and affordability offered by Shiny. Other dashboarding tools didn't come close to meeting our needs. We are highlighting our use of Shiny in local government because our school district has an elected school board of directors serving students across multiple municipalities with their own elected leadership. The driving force behind the development of the app was to democratize access to school information. Other organizations, such as Great Schools, focus on rating, grading, and ranking schools. With School Insights, we control our own data story by focusing on a more holistic view of what makes schools outstanding within their local context. We use both academic and non-academic information to provide a robust, consistent portrait of each school. With a bit of background on our work, we will now share some of the technical aspects of School Insights. We carefully designed the layout of the Shiny app with multiple feedback cycles from end users. This led to our use of Shiny Dashboard Plus features to organize content and create a consistent user experience within and between tabs. The style elements used are aligned with our organization's branding and are sourced from a cascading style sheet file that is used throughout this app and shared between other apps we deliver. Since we broadened the scope of who is viewing information, we sought to make the app as accessible as possible. School Insights allows users to leverage web accessibility features powered by UserWay, such as allowing users to increase text spacing or alter the color contrast. Additionally, we also used AI-powered language translation with Google Translate. By placing just this small bit of JavaScript in the body of the app, users can readily select from languages other than English. The use of translation introduced the problem of translating ggplot. Since ggplot output is an image, we had to leverage the giraffe package to allow users to access plots in languages other than English using hover features. In the example provided here, we use Geombar Interactive to translate the tooltip text from English to Spanish. To foster use by community members without ready access to technology, we provide a print-based option. This option also allows users to capture written notes and reflection. As we mentioned earlier, there are some complexities built into the project, such as the need to handle a wide variety of school configurations and the need for some data suppression. In the data suppression example, we do not offer data for schools with too little information to make strong inferences from. Here we use a simple conditional to detect and handle such cases. This example conditional detects if the data filtered to one school has one or more rows of results. If that's true, then render the plot. If not, do not render the plot. This and other coding choices streamline the user experience. Since there is some variability on the data reported and collected, we use Shiny's ability to hide tabs from view. For instance, high school students are not tested on early literacy skills, so we completely remove tabs reporting these data from the user's view. In the example code shown here, if the selected school is a high school or middle school, hide the tab that displays early literacy results. All coding choices can be accessed in our GitHub repository with the link provided at the end of this video. Another customization need emerged as the app was distributed throughout school communities. We learned that users did not want to have to select their school from a list of over 150 sites. They wanted a direct link to their school of interest. To provide a custom URL for each school location, we set up an association between the unique school's numeric code and its name using baseR's name function. We then populated the schools to a list in a select input. Next, we set up a Shiny Observe to query inputs provided in the browser URL. This allows school websites to link directly to their information, supporting targeted access and use. As people engaged with the app, we sought to learn more about their use. We linked Google Analytics to School Insights to accomplish this. Through the data collection process, we learned that we have over 20,000 users since our launch. This backend data collection additionally allows us to learn how much time users are spending on the app, where in the world they're accessing from, and how they flow through the app. These and other metrics inform our continued development. A key takeaway from our learning is that Shiny can be used to broaden access to key indicators of success and progress. Learning resources, including those in the online community, made it possible for us to use the flexibility offered by Shiny. This level of customization was not readily available with other business intelligence software. Through continued work with our community, we now provide well over 100,000 data points for engaging in data-informed improvement planning. You can explore insights at the links provided here, including our GitHub repository. We are so honored to have this opportunity to present our work to you. We hope you enjoy the conference.